Hi, I'm Connor Malone, and I'm going to be taking you through our ICCV paper, a hyperdimensional one-place signature to represent them all, stackable descriptors for visual place recognition. The problem that we tackle in this work is visual place recognition, which is fundamentally a localization solely based on images. So we traverse throughout the environment and store a reference database of images from previously visited places, and then when re-navigating the environment, we compare a query image of the current location to our database of reference images to know where we are. The method that we introduce in this work relies on the concept called hyperdimensional computing. Now, this is essentially a framework in a similar way to how linear algebra is a framework, encompasses a set of vector operations and takes advantage of numeric and geometric properties. There are two main operations in hyperdimensional computing that are relevant to this work: bundling, which aims to create superpositions, and binding, which creates associations. The particular operation that we use is bundling with this work, which combines or overlays multiple vectors together. We adopt the element-wise sum method, which is used. However, there are alternative ways of bundling vectors together. Some of the important properties of this bundling operation is that the output vector is similar to all inputs. This is because large dimensionality means that most other vectors are actually essentially orthogonal to this created vector compared to its inputs. Now, multiple vectors can be bundled together, not just two, so 3, 4, even hundreds. This is an important thing for how we use this bundling operation in this work. We use it in the case of a multi-reference visual place recognition problem. So for multi-reference visual place recognition, there can be multiple references of the same place which can be used for localization. Now, this can improve performance when you capture the location under different sorts of conditions. So this might be nighttime, sunset, rainy, or even snow conditions. However, typically the techniques used to perform this multi-reference visual place recognition increase computational overhead and memory requirements during matching. So this is because we can essentially pull all the different images together in the basic naive way, and we can just compare our query to all different images individually. So this substantially increases the computational and memory requirements. This can be improved by instead comparing our query image to all reference sets individually, and then aggregating the similarities from each of these reference sets to do a final VPR estimation. This allows parallelization of computations. However, there's still a slight increased computational cost, and it doesn't improve the memory requirements in this multi-reference visual place recognition. In this work, we therefore propose that you can use hyperdimensional computing bundling to bundle different images or descriptors of the same place together into a single descriptor. This work assumes that they are captured under different conditions and that they have a relatively similar viewpoint at this point. We're able to then bundle these into a single descriptor to improve the robustness to different adverse conditions. We utilize multiple reference sets, but with the complexity of one. This substantially decreases the computational overhead and the memory footprint, and improves the robustness in adverse conditions, even unseen ones. Importantly, we can use this bundling operation with any state-of-the-art or any VPR descriptor base. Here are some of the results that we were able to achieve during this work. So as you can see, we tested across several different state-of-the-art VPR descriptors and multiple different adverse conditions and saw improvements across all of them. We saw in 87 out of 90 experiments improved results with varying data sets and VPR descriptors. It's important to note that in these results, the test condition is always excluded from the bundled descriptor. So for example, when testing on the rain dataset as a query, this dataset is removed from the bundled reference so that the reference descriptor has never seen a rain dataset before. There are lots of further opportunities we see for using hyperdimensional computing in visual place recognition. For example, one that we include an initial study on is dataset or map compression. So what if we take all the images from a single dataset and we bundle them into a single descriptor which can be used to describe that dataset? If you don't know which dataset or map a query is from, you can then perform image retrieval using these single dataset descriptors to determine which dataset your query is from. We show that this can classify queries into datasets with greater than 98% accuracy. Other things that we think we can look into is bundling different viewpoints from the same place together and stacking or bundling multiple maps into a single reference dataset. Thank you for listening, and please come and check out my poster and ask me any questions you like at ICCV.